Welcome back to Mrs. Riley's Maths videos. Today we're looking at functions. This may be an introduction to you, but I'm doing it as a quick functions revision video for my senior classes, but it may also answer your questions if you have particular questions about functions. So what I'm looking at today is I'm looking at mapping diagrams and looking at functions notation, and for some reason it's blank, but we might fill it in later on. Okay, so a very quick review of what a function is. So if I draw a picture of what a function is in kind of just a picture to help you understand, a function is like a box. So this is a function box, and what happens is we feed numbers into the function box and we get numbers out. So a bit like in a factory, you feed something into the box and the box does something to the numbers and it puts numbers out. The numbers we put in are called inputs and the numbers we get out are called outputs. There's another name for the inputs as well, which is called the domain, and the outputs are called the range. So inputs are domain, outputs are called range. So for example, let's say we had a function box which was 5x. What would happen would be we'd put a number into that function box, so we'd put 3 in and we'd get 5 times x is what the function is. We'd get 5 times 3 out, so our output would be 15. Say we put in minus 2 into the function box, 5 times minus 2 is minus 10. Say we put 0 into the function box, 5 times 0 is 0. And let's say one more, say we put a into the function box, we'd get 5 times a, which is 5a. So a function is like a box that we put numbers into, or we put letters or expressions into, and we get another letter or expression or number out. Okay, in maths, the functions that we deal with, we have linear functions, which are lines. Okay, so there's an example of a linear function. We have quadratic functions, and linear and quadratic functions are in the Junior Cert course, quadratic functions which look like that, or may look like this. This is a plus x squared, this is a minus x squared. We have exponential functions, which you'll have heard talked about a lot during COVID-19. So exponential functions, they're a bit weird. They have the shape where they just start off really slow and then they shoot up. That's an exponential function. And then in Leaving Cert we have cubic functions, which can have either this shape or could have, if I can fit it down here, the other shape of a cubic would be like this. So that's cubic and that's a cubic. We'll worry about those again. So those are functions. In each of these, as you can see, the x value has a y value that goes with it. So in a linear function, each x value has a y that goes with it. Okay, here's the x, this is the y that goes with it. And hopefully you're used to reading those points from your graphs. Again, quadratic, exponential, and cubic. And in fact, the definition of a function is that because these are also called relations, but the definition of a function is that each input only has one output. Each input only has one output. When we come to mapping diagrams, and that's very important, that the definition of a function is each input only has one output. In other words, for each x, there's only one y. So these are diagrams of functions here, or graphs of functions here. There's another way that we're asked to represent functions, and that's in a mapping diagram. So mapping diagram. And in a mapping diagram, what we end up doing is we have two circles. And one circle represents the domain, and one circle represents the range. So remember, one circle represents the inputs and one circle represents the outputs. So if we take our function over here, 5x, this is our function 5x, our domain was 3, minus 2, 0, and a, and our range was 15, minus 10, 0, and 5a. Now let's just put another number in there, say let's just put 20, and I'll explain about that in a moment. So my mapping diagram would have me drawing 3 to 15 with an arrow, minus 2 to minus 10, because 5 times minus 2 is minus 10, 5 times 0 is 0, 5 times a is 5a. And what we would say the couples of the function would be 3, 15, minus 2, minus 10, 0, 0, and a, 5a. If you can recognize there, I hope that they're looking like points from drawing a graph, like coordinate points. Okay, so mapping diagram, domain, range, inputs, outputs. Remember, each input only has one output. Now you'll have noticed here that 20 is here, but it doesn't have an arrow going to it, and we'll come to that in a moment, because what we can do also is, as well as listing the couples of the function, we can list the domain would be 3, minus 2, 0, and a. We use curly brackets, sets brackets for this. The range is 15, minus 10, 0, and 5a. And now there's a thing called the codomain, which I'm always a bit, anyway, people always find it a bit puzzling. The codomain is anything in this range circle. So even though it's got the name domain in it, it's actually referring to the range. Anything that's in that set there of that circle is the codomain. So that includes all those that have arrows going to them and are in the range, but also anything else, which in this case is 20. So 20 is part of the codomain, but it's not part of the range. Okay, so that's what we have so far with functions. Let's go on to function notation. Oh, sorry, just one last thing. You might be asked, is something a function or not? So let's draw something that isn't a function. 3, 6, 9, 13, 7. Say you had a function and the picture looked like this. 10, 4, minus 2, minus 9, 8, and 12. The function looked like this. And you had 3 going to 10, and you had 7 going to 4, and you had 6 going to minus 2, and also to minus 9. And you had 9 going to minus 2, and 9 going to 12, and you had 13 going to 8. If you see here, there are 2 arrows going from an element in the domain to an element in the range. There's 2 arrows, so this is not a function. Okay. However, if we had a smaller one here, let's say 3, minus 3, and 4, and we had 9 and 16, if this was the function x squared, well, 3 would go to 9, and minus 3 would also go to 9, and 4 would go to 16. This is a function, because each input only has one output, which is 9 here, or 16, whereas here some inputs have 2 outputs, so they're not functions. So this is a function and this is not a function. Okay, over now to function notation. Let's keep moving. Function notation. Okay, so function notation. So we have this box, remember, and we said let's take a different function this time. Let's say it's 3x plus 4. So whatever number we put in, we get 3x plus 4 is what happens to it. And we get a number out. Remember, this is our domain, or our inputs. This is our range, or our output. So say we put in 2. In function notation, we have a maths way of writing what we're doing. And what we're saying is f of 2 is how we put it. F being function, 2 being the input. Okay, so what we're saying, the function of 2. If I put 2 into my function, that's what that means. If I put 2 into my function, that's what that means. Okay, f of 2 equals 3 by 2 plus 4 equals 6 and 4, which is 10. So what I can say is f of 2 equals 10. If I put 2 into my function, it's 3 times 2 plus 4. The output is 10, and this is called f of x. Okay, so f of x here refers to output. F of 2 means I put 2 in. I'll come back to this f of x business in a minute, because if I continue with it now, it won't make that much sense. So say I told you that function x is equal to 3x plus 4. This is an example. Okay, function x is equal to 3x plus 4, and I say find f of 2. Well, we just had to f of 3. F of 3 is going to be 3 by 3 plus 4, which is 9 plus 4, which is 13. So f of 3 equals 13. Find f of minus 5, which equals 3 by minus 5 plus 4, which is minus 15 plus 4, which is minus 11. So f of minus 5 equals minus 11. Say it was f of 4a, that would be 3 by 4a plus 4, which would be 12a plus 4. So f of 4a equals 12a plus 4. And now, say if I asked you to find a value for t so that f of t is equal to minus 26. So f of t is equal to minus 26, but f of t is also equal to 3t plus 4, because remember f of x was equal to 3x plus 4, so f of t is equal to 3t plus 4. So f of t is equal to 3t plus 4, and that equals to minus 26. So 3, now we've got an equation, haven't we? 3t plus 4 is equal to minus 26. So subtracting 4 from both sides, 3t is equal to minus 30. Divide by 3, divide by 3, t is equal to minus 10. Okay, so what we found out is that if f of t is equal to minus 26, then t must be 10, because f of minus 10 is equal to minus 26. Okay, hopefully that makes sense for function notation, and we'll do some more difficult examples in the next video. Thank you.